Now, in this chapter, we're going to be talking about non-experimental designs. Non-experimental designs are used when the researcher wishes to construct a picture of a phenomenon, explore events, people, or situations as they naturally occur, or test the relationships and differences among variables. Non-experimental designs, the independent variable is not manipulated. Subjects are not randomized. There is no control group, and it provides level 4 evidence. As you can see, these designs are not as powerful as experimental designs. However, they are used to start moving toward the development of an experimental design. When a phenomenon is very new, such as an addiction to electronic devices, the researcher would want to know everything about the addiction so that she would know it when she sees it. That would be done using descriptive research. Then she may want to know if addiction is any way related to being shy or lonely. The researcher would then collect data on the variables of using electronic devices and the variable of being shy and statistically look at them to see if overuse of electronic devices could be related to being shy. This is correlational research. If that is true, then an experimental design could be done to examine if a program to reduce shyness would decrease the addiction to using electronic devices. What this does is to save a lot of research dollars being spent on interventions that make little or no sense. However, remember my caveat, correlation does not mean causation. Now, in your book, it talks about surveys as being a type of non-experimental design. In this course, I'm going to require that you dig deeper to find out whether it is descriptive, exploratory, or comparative. Surveys, I sometimes think of as just being a way to collect data. And as the slide says, it collects detailed descriptions of existing variables. And as you can see, surveys are used to justify and assess current conditions and practices or to improve healthcare practices. The terms exploratory, descriptive, comparative, and survey may be used either alone, interchangeably, or together to describe the design of a study. Now, surveys are called comparative when they're used to determine differences between variables or groups. And data is collected through questionnaires or interviews. In surveys, samples may be very small, large, broad, or narrow. But remember, they do not attempt to determine causation. They seek to relate variables to each other. Now, there are some disadvantages to surveys, meaning that information obtained in a survey tends to be broad but superficial, and conducting a survey requires expertise in several research areas, and large-scale surveys can be very time-consuming and costly. Now, in this class, I'm going to be asking you to determine the type of design that is in your article. And these are the two types of descriptive designs that I'm going to ask you to be aware of. There's a typical descriptive design, and there's the comparative descriptive design. And the information that I'm giving you now is not in the text, but is of importance. A descriptive design may be used to develop theories, identify problems with current practice, justify practice, make judgments, or determine what others in similar situations are doing. Remember, there's no manipulation of variables in the descriptive design. Dependent and independent variables are not used because there's no attempt to establish causality. What is desired is a clearer description of the phenomenon. Now, there's protection against bias, and that is achieved through conceptual and operational definitions of the variables, sample selection and size, valid and reliable instruments, and data collection procedures that partially control the environment. The comparative design is used to describe variables and to examine the difference in variables between two groups that occur naturally in a setting. Both descriptive and inferential statistics may be done, but the results are not generalized to a population. An example of a descriptive design purpose might be, the purpose of this study was to describe the barriers to entering the healthcare system among the rural poor in Alaska. The key word in the purpose statement that leads you to knowing that it is a descriptive design is the word describe. The variables to be measured are barriers to healthcare, and usually you can find these in the instrument section of the article, and we're going to be working on that in class. And the population is the rural poor in Alaska. An example of the purpose of a comparative descriptive study is as follows. The purpose of this study is to compare barriers to entering the healthcare system between the rural poor in Alaska and the urban poor in Chicago. You can see that the variables are still barriers to healthcare, but now there are two groups of people who are being compared. Correlational studies, on the other hand, examines the association between two or more variables. And what they want to know is, do the variables co-vary? It's interested in quantifying the strength and distinction, positive or negative, of the relationship. Advantages for correlational studies are increased flexibility in investigating complex relationships, and it's rather an efficient method to collect a large amount of data. Furthermore, correlational studies can be a foundation for future experimental studies and a framework for exploring the relationship between variables that cannot be manipulated. Now, there are two types of correlational design. They're descriptive and predictive. And the purpose of a correlational design is to examine relationships between and among two or more variables in a single group. The exam may lead to a description of the relationship, and on the other hand, it can predict a relationship. The purpose of a descriptive correlational design is to describe the variables and examine the relationship among variables. Remember, there's no attempt to control or manipulate the situation, and the variables must be clearly identified. One statistical test you may see is the Pearson product moment, and the symbol for this is a small r. And you may find them in the results section of the article that you're reading. And that's another hint to that it is a descriptive correlational study design. The purpose of a predictive correlational design is to predict the value of one variable based on the value of another variable. In this instance, causal phenomena are being examined, therefore there are dependent and independent variables. The statistics you may read are called multiple regression or multiple variate statistics, and the statistical symbol you may see is a capital R. An example of a purpose statement for a descriptive correlational study is, the purpose of the study is to determine if there is a relationship between social support and recovery from an amputation of a lower limb in men over the age of 65. The key word is relationship, and the variables to be measured are social support and recovery from amputation. The population is men over the age of 65. An example of a purpose statement in a predictive correlational study is, The purpose of this study was to determine if social support can predict recovery from amputation of a lower limb on a population of men over the age of 65. The key word in this is to predict, and the variables in population are the same as the above purpose. I am putting up this slide to help you in determining the design of a research study, which can be quite difficult. So each time that you try to answer a question I have, either on a critique or on a quiz, I want you to follow this flow chart because you're going to find it very helpful. So if we start at the top, the first question you must answer is there a treatment? If the answer is yes, then you only have two types of designs from which to choose, experimental and quasi-experimental. To decide between those two designs, you will have to look at the study and determine if there's a control group and randomization. You've already determined that there was a treatment or manipulation. If the study has a treatment, control group, and randomization, then it is experimental. If one of them is missing, then it is quasi-experimental. If there is no treatment, then it will either be a descriptive or correlational study. Remember, I will not accept just stating that it is a survey study or non-experimental because that is just an umbrella statement. If the purpose is to describe, we will move to the flow chart for descriptive studies. That's the next slide. And if the purpose is either to describe or predict a relationship, we will go to the flow chart for correlational designs, which is the one following. Now, if you have determined that the purpose is to describe, you must decide if there is only one group or two groups that the researcher is describing. If there is only one group, then it is a purely descriptive design. If there is more than one group, then it is a descriptive comparative design. And in the statistics section of the article, for purely descriptive design, they're only going to have descriptive statistics, and we're going to talk more about those later. And for the descriptive comparative design, they may use a t-test. If you decided that the study is determining a relationship, then you have to decide if it is descriptive correlational or predictive correlational. The difference lies in the term predictive, which is the hint. You also may see the term multiple regression, multivariate statistics, or logistic regression in the statistics section. Then it is most likely a predictive correlational design. What I want you to remember is that researchers many times combine research designs. Now, the material in the next few slides are not in your textbook. I wanted to go over them because when you go to grad school, these types of designs will be found in a class about epidemiology, and these are designs that are of importance to advanced practice nurses in determining what intervention should be given to their patients. Now, epidemiologic designs are concerned with relationships and differences among phenomena at one point in time, but also with changes that occur over time. And the first one we're going to look at is cross-sectional. Cross-sectional designs examine data at one point in time. Data are collected only one time. Cross-sectional epidemiologic designs are the first studies done in a population to determine the extent of a health problem such as lung cancer. It is much like descriptive design and research, but it is used to determine if the health condition is prevalent and to what extent does it affect a group of people. You can think of it as a snapshot. Now, there are advantages to cross-sectional designs. One is that they are less time-consuming and less expensive. Large amounts of data can be collected at one point, making the results more readily available. The confounding variable of maturation resulting from elapsed time is not present. Well, some of the disadvantages are that it's difficult to establish a developmental assessment of the interrelationship of the phenomena. In other words, as with descriptive designs, cross-sectional designs cannot determine cause and effect. Now, the second epidemiologic design I'm going to talk about is case control. This examines a population for a health problem and attempts to associate the health problem with a preceding event. After an epidemiologist has determined that a health problem exists in a population to a degree that warrants investigation, the epidemiologist will try to determine a link between the health problem and an event in the past. The process includes gathering two groups of people from the same population and then dividing them into two groups. One group will not have the problem of concern and the other will not. Then the researcher looks into the past of both groups to determine who may have been exposed to the link. Then an odds ratio will be determined, which will tell the researcher if the presumed antecedent event is linked to a health problem. If the odds ratio turns out to be greater than 1, then the researcher is on the right track. For example, in lung cancer, it was thought that smoking was the antecedent event. So epidemiologists studied a population to determine who had lung cancer and who did not. Then they questioned the groups about smoking. After doing an odds ratio, it was determined that smoking was indeed linked to lung cancer in a big way. You can think of this as a flashback study. As you can see, I have not used the term cause, since case control studies still do not determine cause and effect. It's kind of too deep to go into in this course. The last epidemiologic design will be cohort. Cohort designs collect data from the same sample at different points in time. They explore relationships and correlations or differences and comparisons or both. They are also called repeated measures studies. Cohort designs are the best designs for epidemiologists. In this type of study, groups of people are chosen from a population. Both of them are free from a specific disease being studied, but one group has been exposed to some factor that contributes to the disease. Then the groups are studied over time and it is determined who developed the health concern of interest. The calculation is called a relative risk, and anything over 1 is considered to be the link. For example, using our smoking and cancer study, the epidemiologist would choose two groups of people, both free from lung cancer, but one group who smokes and the other does not. The groups would be followed over time and it would be determined who developed lung cancer. You can think of this as a motion picture. There is a retrospective cohort design in which the epidemiologist goes back in the medical records or databases and looks for groups that are free of the disease, but one group has had an exposure and the other has not had the exposure. Then the researcher looks forward in the medical record or data banks to determine if the exposed group got the health condition or not. Now, advantages to cohort designs is early trends in the data can be analyzed, and they assess changes in variables over time, and both relationships and differences can be explored between the variables. Disadvantages include that data collection can take a very long time, increasing costs in time, effort, and money. And testing effects may be a threat, And mortality, which you remember can also include loss of participants, not death, is a significant threat owing to the increased potential for attrition. Now, I've put up on this slide the differences between prospective and retrospective cohort designs. In prospective are less common, slow, and expensive. It has stronger evidence, better control of extraneous variables, and findings suggest associations or relationships. Retrospective is common, faster and cheaper, has weaker evidence, less control of extraneous variables, and findings suggest association or relationship. Neither study establishes cause and effect. Only experimental studies can support cause and effect. The terms prospective and retrospective are important in epidemiologic studies. Prospective is like our motion picture, and retrospective is like our flashback. And this is the end of the design lectures.